The mineral or gemstone chrysoberyl is an aluminate of beryllium. The name chrysoberyl is derived from the Greek words chrysos, and berylos, meaning a gold-white spar. Despite the similarity of their names, chrysoberyl and beryl are two completely different gemstones. Although they both contain beryllium, chrysoberyl is the third. Artists frequently encountered natural gemstone and lies at 8.5 on the Mohs scale of mineral hardness between corundum 9 and topaz 8. An interesting feature of its crystals are the cyclic twins called trillins. These twin crystals have a hexagonal appearance, but are the result of a triplet of twins with each twin oriented at 120 deg to its neighbors. If only two of the three possible twin orientations are present, V-shaped twin results. Ordinary chrysoberyl is yellowish, green, and transparent to translucent. When the mineral exhibits good pale green to yellow color and is transparent, then it is used as a gemstone. The three main varieties of chrysoberyl are ordinary yellow to green chrysoberyl, cat's eye or cymophane, and Alexandrite. Yellow-green chrysoberyl was referred to as chrysolite during the Victorian and Edwardian eras, which caused confusion since that name has also been used for the mineral olivine pyridite as a gemstone. That name is no longer used in the gemological nomenclature. Alexandrite, a strongly pleiotroic trichroic gem, will exhibit emerald green, red, and orange, yellow colors depending on viewing direction in partially polarized light. However, its most distinctive property is that it also changes color in artificial tungsten halogen light compared to daylight. The color change from red to green is due to strong absorption of light in a narrow yellow portion of the spectrum, while allowing large bands of more blue-green and red wavelengths to be transmitted. Which of these prevails to give the perceived hue depends on the spectral balance of the illumination. Fine quality Alexandrite has a green to bluish green color in daylight, relatively blue illumination of high color temperature, changing to a red to purplish red color in incandescent light, relatively yellow illumination. However, fine color material is extremely rare. Less desirable stones may have daylight colors of yellowish green and incandescent colors of brownish red. Cymophane is popularly known as cat's eye. This variety exhibits pleasing chatoyancy or opalescence that reminds one of the eye of a cat. When cut to produce a cabochon, the mineral forms a light green specimen with a silky band of light extending across the surface of the stone. Chrysoberyl forms as a result of pegmatitic processes. Melting in the Earth's crust produces relatively low density molten magma, which can rise upwards towards the surface. As the main magma body cools, water originally present in low concentrations became more concentrated in the molten rock because it could not be incorporated into the crystallization of solid minerals. The remnant magma thus becomes richer in water and also in rare elements that similarly do not fit in the crystal structures of major rock-forming minerals. The water extends the temperature range downwards before the magma becomes completely solid, allowing concentration of rare elements to proceed so far that they produce their own distinctive mineral. The resulting rock is igneous in appearance but formed at a low temperature from a water, rich melt, with large crystals of the common minerals such as quartz and feldspar, but also with elevated concentrations of rare elements such as beryllium, lithium, often forming their own minerals. This is called a pegmatite. The high water content of the magma made it possible for the crystals to grow quickly, so pegmatite crystals are often quite large, which increases the likelihood of gem specimens forming. Chrysoberyl can also grow in the country rocks near to pegmatites when B and Al-rich fluids from the pegmatite react with surrounding minerals. Hence, it can be found in nica schists and in contact with metamorphic deposits of dolomitic marble because it is a hard, dense mineral that is resistant to chemical alteration. It can be weathered out of rocks and deposited in river sands and gravels in alluvial deposits with other gem minerals such as diamond, corundum, topaz, spinel, garnet, and tourmaline. When found in such places, it will have rounded edges instead of sharp, wedge-shaped forms. Much of the Chrysoberyl mined in Brazil and Sri Lanka is recovered from placers, as the host rocks have been intensely weathered and eroded. If the pegmatite fluid is rich in beryllium, crystals of beryl or chrysoberyl could form. Beryl has a high ratio of beryllium to aluminium, while the opposite is true for chrysoberyl. Both are stable with the common mineral quartz. For Alexandrite to form, some chromium would also have had to be present. However, beryllium and chromium do not tend to occur in the same types of rock. Chromium is most common in mafic and ultramafic rocks, in which beryllium is extremely rare. Beryllium becomes concentrated in felsic pegmatites, in which chromium is almost absent. Therefore, the only situation where an alexandrite can grow is when B, rich pegmatitic fluids react with quartz-rich country rock. This unusual requirement explains the rarity of this chrysoberyl variety. The alexandrite variety displays a color change dependent upon the nature of ambient lighting. Alexandrite results from small-scale replacement of aluminium by chromium ions in the crystal structure, which causes intense absorption of light over a narrow range of wavelengths in the yellow region 520, 620, 620 nm of the visible light spectrum. Because human vision is most sensitive to green light and least sensitive to red light, alexandrite appears greenish in daylight where the full spectrum of visible light is present, and reddish in incandescent light, which emits less green and blue light. This color change is independent of any change of hue with viewing direction through the crystal that would arise from pleochroism. Alexandrite from the Ural Mountains in Russia can be green by daylight and red by incandescent light. Other varieties of alexandrite may be yellowish or pink in daylight and a columbine or raspberry red by incandescent light. Stones that show a dramatic color change in strong colors, red to green, are rare and sought after. But stones that show less distinct colors, yellowish green changing to brownish yellow, may also be considered alexandrite by gem labs such as the Gemological Institute of America. According to a popular but controversial story, alexandrite was discovered by the Finnish mineralogist Niels Gustaf Nordenskiöld 1792, 1866, and named Alexandrite in honor of the future emperor of all Russia, Alexander I. Nordenskiöld's initial discovery occurred as a result of an examination of a newly found mineral sample he had received from Perovskii, which he identified as emerald at first. The first emerald mine had been opened in 1831. However, recent research suggests that the stone was discovered by Yakov Kolkovin. Alexandrite 5 carats, 1,000 meg, and larger were traditionally thought to be found only in the Ural Mountains, but have since been found in larger sizes in Brazil. Other deposits are located in India, Andhra Pradesh, Madagascar, Tanzania, and Sri Lanka. Alexandrite in sizes over 3 carats are very rare. Today, several labs can produce synthetic lab-grown stones with the same chemical and physical properties as natural andrite. Several methods can produce flux, grown alexandrite Sokrovsky, or pulled alexandrite, and hydrothermally produced alexandrite. Flux-grown gems are fairly difficult to distinguish from natural alexandrite as they contain inclusions that seem natural. Sokrovsky, or pulled alexandrite, is easier to identify because it is very clean and contains curved striations visible under magnification. Although the color change in pulled stones can be from blue to red, the color change does not truly resemble that of natural alexandrite from any deposit. Hydrothermal lab. Grown alexandrite has identical physical and chemical properties to real alexandrite. Some gemstones falsely described as lab-grown synthetic alexandrite are actually corundum laced with trace elements, e.g., vanadium or color change spinel, and are not actually chrysoberyl. As a result, they would be more accurately described as simulated Alexandrite rather than synthetic. This Alexandrite, like sapphire material, has been around for almost 100 years and shows a characteristic purple mauve color change, which does not really look like Alexandrite because there is never any green. Cymophane has its derivation also from the Greek words meaning wave and appearance, in reference to the haziness that visually distorts what would normally be viewed as a well-defined surface of a cabochon. This effect may be combined with a cat eye effect. In this variety, microscopic tube-like cavities or needle-like inclusions of rutile occur in an orientation parallel to the C-axis, producing a Chatterton effect visible as a single ray of light passing across the crystal. This effect is best seen in gemstones cut in cabochon form perpendicular to the CE axis. The color in yellow chrysoberyl is due to Ph3 impurities, although other minerals such as tourmaline, scapolite, corundum, spindum, spinel, and quartz can form cat's eye. Stones similar in appearance to cymophane. The jewelry industry designates these stones as quartz cat's eye or ruby cat's eyes, and only chrysoberyl can be referred to as cat's eye with no other designation. Gems lacking the silky inclusions required to produce the cat's eye effect are usually faceted. An Alexandrite cat's eye is a chrysoberyl cat's eye that changes color. Milk and honey is a term commonly used to describe the color of the best cat's eyes. The effect refers to the sharp milky ray of white light normally crossing the cabochon as a center line along its length and overlying the honey-colored background. The honey color is considered to be top grade by many gemologists, but the lemon yellow colors are also popular and attractive. Cat's eye material is found as a small percentage of the overall chrysoberyl production wherever chrysoberyl is found. Cat's eye became significantly more popular by the end of the 19th century when the Duke of Connaught gave a ring with a cat's eye as an engagement token. This was sufficient to make the stone more popular and increase its value greatly. Until that time, cat's eye had predominantly been present in gem and mineral collections. The increased demand, in turn, created an intensified search for it in Sri Lanka. Thank you for watching. Don't forget to please like and subscribe. If you have a topic you would like to suggest, leave a comment.